Hello, I'm Lou Bloomfield and this is How Things Work. Today's topic, carousels and roller coasters. Up till now, we've looked at acceleration as something that happens to other things, maybe even other people. But now we're going to bring it home to ourselves and see what it's like to accelerate. What do we feel? And it turns out that we essentially feel our own inertia, our own tendency not to accelerate. And as a result, we experience what feels an awful lot like gravity. It isn't gravity, but it feels like gravity, except it doesn't necessarily point down anymore, and it's not necessarily of the right strength. It's not equal to our weight. So, before looking at that experience of acceleration, let's look again at what acceleration itself is. It's any change in velocity. Or more technically, acceleration is the rate at which velocity is changing with time. And velocity, after all, is a vector quantity. It has an amount, which we call speed, and a direction, which is where you're going, the direction in which you're heading. So if you change either one or both, speed and or direction of travel, you're accelerating. That means that if you speed up or slow down, yes, you're definitely accelerating. But even if you just change direction, you're accelerating as well. Well, when is a case where you're traveling at constant speed but changing direction? And an example of that is when you're riding the carousel. The carousel goes around and around at a steady angular velocity, and since you're sitting at a certain point away from the pivot, you're traveling around at a constant speed, but not a constant direction. In fact, your direction is always tangent to the circle, that is, along the circumference of the circle that you're traveling in. But your acceleration, oddly enough, is to your left, if you're traveling like I am, toward the pivot. You're accelerating always toward the pivot. Round and around as you go. So this is a strange or unusual case in which your velocity and your acceleration are at right angles to one another. The exact amount of that acceleration, well, we can do that. Mathematicians and physicists certainly care about that. But the main thing is, the faster you go around in that circle, and therefore the more rapidly your velocity is changing, of course, the more you're accelerating, the more intensely you're accelerating towards that central pivot. Okay, so that's a case where acceleration occurs even though you're moving at constant speed. And even if you're not on a carousel, you experience the same effect when you're making a turn on a bicycle, or while you're running around a track, or while you're driving around a curve. You're accelerating typically toward the center of that arc. The exact location of the direction, the exact direction in which you're accelerating depends a little bit on the exact structure of the curve and how you're going through it. But in any case, you're accelerating despite not changing speed. Okay, that said then, what's the experience of accelerating like? Well, to start with, what's the experience of just weight itself, of having gravity act on you? We've lived this our whole lives. What's going on? Why do we sort of feel heavy? Well, in part, standing here, I feel the floor pushing against my feet. The floor is supporting my weight, but that support is not exerted uniformly through my body at the locations where all my pieces of weight are. Instead, that support is exerted on my feet. And therefore, my feet are pushed up, and they're then responsible for pushing up on my ankles, which are in turn to support them, which in turn support my knees, and they work there all the way up to my body to support my head and so on. So I feel all these internal stresses of parts of my body pushing on other parts above them to support them, and the weight of everything above them. And that's our experience of weight, is all those internal stresses. All right? So what's an alternative? Suppose I'm in a car, and let's imagine there's a back on this stool, and I'm going to accelerate to the right. We're stopped at a red light, and the light turns green, and I stomp on the accelerator. Whoa, we accelerate forward. Well, during that forward acceleration, all the parts of my body want to keep doing what they were doing. They want to be inertial. They want to stay back there and let the car just drive out from under me. But no, the seat back and other parts of the car push on me to try to make me accelerate. Well, again, they can't push on all the little parts of me simultaneously to get all those little pieces of mass moving, accelerating forward uniformly. Instead, the parts of the car push on my back surfaces to cause the acceleration. So my back then becomes responsible for pushing forward on my middle to make my middle accelerate, which in turn is responsible for pushing forward on my front to make my front accelerate. So there are a whole lot of internal stresses in my body trying to get all of me accelerating forward together. And I feel those internal stresses, and they feel just like weight, except the direction of this seemingly weight, what I will call the feeling of acceleration. So that's my formal name for it, feeling of acceleration. The direction of that feeling of acceleration has nothing to do with gravity. Instead, it's exactly opposite the direction in which you're accelerating. So I'm, in my hypothetical car here, I'm accelerating to your right, and therefore I feel a feeling of acceleration toward your left. And how strong is that feeling of acceleration? Well, it depends on how fast I'm accelerating. If I'm accelerating at 9.8 meters per second squared, which is the same amount as the acceleration due to gravity, I will experience a feeling of acceleration, opposite my acceleration, that's just as strong as my feeling of weight. I won't be able to tell the difference between the two, in fact. The feeling of acceleration and the feeling of weight are indistinguishable. So if you accelerate at the acceleration due to gravity, you'll feel a 1 gravity strength or 1 g strength feeling of acceleration in the direction opposite that acceleration. So if I slam on the accelerator in my car and I have good, really nice traction on my tires, and I accelerate forward at 9.8 meters per second squared, I will feel simultaneously my real weight downward due to gravity, because that's not going anywhere, and a feeling of acceleration backward that feels just as strong as gravity. And those two feelings will add in my experience. I'll feel them together, and I will feel as if I have an extra strong weight with what I call an apparent weight, the combination, the sum of my real weight and the feeling of acceleration. I'll have an apparent weight down and back, the sum of those two vectors. And it will be, actually, it'll be in that direction, and it'll be the square root of 2 times as strong as my normal weight, about 1.4 times my normal weight, down and back. The exact value doesn't matter, but the basic idea is whenever you're accelerating, you feel a feeling of acceleration opposite the acceleration, and it's the strength of that feeling of acceleration is proportional to how rapidly you're accelerating. And your overall experience then is the sum of your real weight and your feeling of acceleration, which I combine together to call your apparent weight. So that said, what do you feel when you're on a carousel going around in a circle? Well, because you're accelerating towards the pivot, the center of the carousel, you feel a feeling of acceleration outward, away from the center of the carousel. And it sure feels like weight, but of course it's not. It's this experience of your own inertia. And as you go around, you're feeling flung outward. This is a common experience when you're going on a playground, merry-go-round, and spinning very fast, or making tight turns and circles, and you feel flung outward. You're not really, there's nothing pulling you outward. There's no outward force in those cases. What you're feeling is your own tendency to go straight. Whenever you're going around the carousel, if no forces act on you, all of a sudden the forces that are acting on you suddenly vanish. you will coast straight. You'll go inertial. And you will travel in exactly the direction you were heading the moment before the forces vanished. And in the case of going around a carousel, that means you leave the carousel, go straight, and off you go into the distance. So that feeling of being flung outward, it's not a force pulling outward. It's that your body wants to go inertial and straight. And this effect is familiar when you take tight turns, say in a car. You feel as though you're flung towards the outside of the turn, and you may even press up against parts of the car during this moment. It's your body trying to go straight, and the parts of the car pushing you toward the center, in the direction you're supposed to accelerate, so that you accelerate with the car and aren't left behind by the car. All right, so that's a carousel's experience, or a merry-go-round, or anything where you're going around in a circle. How about a roller coaster? Well, the whole point of a roller coaster, apart from great visuals if you're in the front seat, or maybe some if you're in the back seat, although there's this issue of if you're not the lead dog, the scenery never changes. So the second car in a roller coaster isn't so great. But okay, you're in the roller coaster, and it does a lot of accelerating. It accelerates left, right, round in circles, forward, backward, and it also accelerates downward at some points. Typically on a steep hill, you're accelerating downward. You're not fully falling, although there are rides in which you truly fall, like drop towers, which are sort of an extreme case of a roller coaster. They don't go very far, but they drop. In any case, whenever you're going through one of these accelerations in the roller coaster, you experience a feeling of acceleration opposite your acceleration. And the strength of that feeling, well, it depends on how fast you're accelerating. So when you go over that first hill and begin to dive downward, to a large extent, you're accelerating downward. It's more complicated than that. You're accelerating down a ramp, really. But the fact that you're accelerating extensively downward means that you experience a feeling of acceleration upward. You feel as though there's an extra gravity pulling you up. It's not that, it's your inertia, again, but you feel it. And that upward-ish feeling of acceleration combines with your true feeling of weight, and they're in largely opposite directions. So they largely cancel one another in producing your apparent weight. You don't feel much apparent weight, it's weak. And your experience then is one of having not much weight all of a sudden. And our bodies respond to that loss of the full weight experience with a bit of a panic, because we associate that with falling, and it's not the falling that's the problem, it's getting to the bottom and hitting things. So whenever you are accelerating downward fairly rapidly, you get an upward feeling of acceleration that to some extent cancels your experience of weight itself, and you feel slightly toward weightless. We'll get to weightless in a moment. And then this causes quite a response in our bodies, that weightless experience. So during the dive, in that first hill, say, of a roller coaster, you feel your apparent weight becomes rather small. And it's, you can say it's terrifying, exhilarating, whatever, boring, if you've done it enough. And then when you get to the bottom of the hill and stop diving downward, you accelerate upward to some extent around a curve. You're traveling around a curve that's curved up, and the pivot, the center point of that curve up, is above you. You're accelerating upward. As a result, you experience a feeling of acceleration downward that to some substantial extent adds nicely with your actual experience of weight, and you feel extra heavy. Your apparent weight is bigger than your normal weight, and still roughly downward. And then as you go around turns and stuff, you feel experiences of acceleration in various directions, and these all create various apparent weights that are fun and interesting. All right, well, I told you what about full weightless? Well, typically you don't do this on a roller coaster. There are some roller coasters that go up and then take you straight down, I suppose, or very close to it. But actually, let's sneak over to the drop tower where they lift you up way up high and then let go and let you drop. Of course, you're in a seat that you drop for a while and then it catches you at the bottom, and it catches you gently, slowly, so it doesn't hurt. Well, during those couple of seconds, 2 seconds is about as much as they can handle based on height, 2 seconds of falling. During that time, you're accelerating downward at the full acceleration due to gravity. And therefore, you experience an upward feeling of acceleration that's just as strong as gravity. It's upward because you're accelerating downward. So when the upward feeling of acceleration is just as strong as gravity, your ordinary weight, if you add your experience of weight and this feeling of acceleration, they perfectly cancel. And your apparent weight is 0. And we say that you're experiencing weightlessness. You are not truly weightless. Gravity's still pulling on you. You still have a weight, but you can't feel it. No stresses. All of you is falling, and everything falls together. Your head falls, your body falls, your legs fall. They're all falling together. No stresses on one another because everybody's just dropping. And during that time, you feel truly weightless, and it's that again is the terrifying, exhilarating, boring, I don't know, whatever you want to feel for it. All right. Last thing to go do is let's go back to the roller coaster and watch you go around a loop-the-loop. When you go around a loop-the-loop, and we'll make it a simple loop-the-loop. The real ones are a little more complicated, but it's basic idea is okay. You're basically traveling in a circle that's sort of a constant speed. It's not truly constant because as you go uphill, you're having to turn some of your kinetic energy into gravitational potential energy. But let's assume that you're approximately traveling at constant speed. Then you are accelerating toward the center of that loop-the-loop. You're traveling a circle, right? You're on it's like a carousel except vertical. All right, so you're traveling a circle. In that case, at various points around this circle, you're accelerating toward the center and therefore experiencing a feeling of acceleration away from the center. At the bottom of the loop-the-loop, you're accelerating up, so the feeling of acceleration is down. You feel extra heavy. At the side of the loop-the-loop, you're accelerating toward the center horizontally, so you get that feeling of acceleration outward. It's not quite right, but it's about the real loop-the-loop life. Life is more complicated because you're changing speeds, rising at that edge. But let's leave it simple. You're accelerating mostly toward the center, and therefore you feel a feeling of acceleration out to the side. And that adds to your weight, and you get an apparent weight that's out here somewhere. At the very top, this is the one that's most interesting and where I'll mostly stop on the story, is you are accelerating downward toward the center of the loop-the-loop. It's below you at the center. You're curving toward that center, and you feel a feeling of acceleration away from the center, which is up toward the sky. And that upward feeling of acceleration can, to some extent, cancels your actual feeling of weight. So your apparent weight is much less than it would be. You're in that weightless area vicinity. And typically they take you around a fast-moving loop-loop so rapidly, you're accelerating so intensely that your upward feeling of acceleration is greater in amount than your actual weight. So that means the upward feeling of acceleration is a stronger effect than your downward weight experience. And when they add together to make your apparent weight, there's a net apparent weight upward. You feel pulled toward the sky. This is, of course, your inertia doing it. There's no actual force up there pulling, but you feel as though up. That's the direction things you're tempted, you effectively would fall. And that means you're pressed into your seat. To create a downward acceleration that strong, more than the acceleration due to gravity, you have to be pushed downward. So I've got a ball here. I can do this. If I take the ball around in a circle fast enough, I'm not gripping it. I'm just making it accelerate downward so fast as it goes over that top that it stays pressed against my hand. It needs my hand to push down on it, to bend its path that fiercely. If I go slower, of course, it falls, right? But I go fast, no problem. And I can put it even in a bucket and take the bucket over the top, and it doesn't fall out of the bucket. It needs the bucket to bend its path in a circle that fast. And so this is how the roller coaster works. The track is necessary to bend the path of the car in that tight a circle, make that intense an acceleration. Gravity alone isn't enough to make that downward bend. So the car is bent by the track, your path is bent by the car, and you feel pressed into your seat, even at the top of that loop, because the car needs to push on you to bend your path, and you consequently push back on the car. You're pressed into your seat. So on a fast-moving loop, at that top point, if you've got your eyes closed, your experience is remarkable. You feel pressed into your seat, and you feel a modest weight-like experience, and your apparent weight that points toward the sky. You can't tell you're upside down. You just feel like, wow, I'm being pulled toward my seat by a weak gravity. Oh, that's actually my inertia doing this. And so that's the experience on a fast-moving loop. When they take you around very slowly around a loop, which they do sometimes, then gravity is strong enough to bend your path, and they actually have to restrain you. They have to clamp things over you to make sure you don't fall out of the car. The slow-moving loop, of course, you could fall out. Fast-moving loop, nope. You stay pressed into your seat because you need that seat to bend your path. Okay, I think I've done this whole story of carousels and roller coasters, and call it a day.